I am M. Sheshachari, a lecturer in chemistry, and today we are going to discuss about the first year organic chemistry. It's one of the very important topic in the further studies, and all the fundamentals are there in the only in the first year, and fundamentals are very easy, and those fundamentals we'll discuss in detail. And just only today we'll discuss about the introduction. What is organic chemistry? So we are going to start the first year organic chemistry. I'm Sheshachari, lecturer in chemistry. And definition of organic chemistry is the study of carbon compounds. Study of carbon compounds is said to be organic chemistry. Carbon is one of the element in the periodic table, and on the base of one element we have a separate branch, and that is organic chemistry. So why the carbon is forming the large number of organic compounds, why not other elements? In the periodic table we have 106 to 125 elements are there. The first element is hydrogen, the next one helium, lithium, beryllium, boron, carbon. Carbon is one of the element in the periodic table. We don't have hydrogen chemistry, we don't have helium chemistry, we don't have iron chemistry, we don't have gold chemistry, but we have a carbon chemistry. Why carbon is forming the large number of organic compounds? What is the reason? What is the reason? Why carbon is forming the large number of organic compounds? Means there are two reasons are there. The first one, carbon can form tetravalency. Valency means the number of single electrons in the last orbit of an atom is said to be valency. Tetravalency. Carbon has 4 unpaired electrons. That is the first reason. The second reason is catenation. Highest catenation property in the periodic table. Then what is catenation? Catenation is the self-linkage of an atom with identical atoms. One carbon linked with the 4 carbons. Again 4 carbons linked with the other 4 carbons. Like that, the self-linkage of an atom with identical atoms is said to be catenation. That catenation property is highest among the 125 elements. So, carbon can have 2 special properties. The first property, highest catenation property. The next property, tetravalency. And these two are responsible for the formation of large number of organic compounds. And if there are 2 compounds, 3 compounds, we can study under one topic. If there are 10 compounds also there, we can study in one topic. But carbon can form millions of compounds. Millions and millions of carbon compounds. So that's why we cannot study under one topic the millions of compounds. That's why we have separated under the separate branch from the chemistry, and that is organic chemistry. Now, what is in organic chemistry means? Organic chemistry is the study of carbon compounds. Now, in the olden days, what is an organic compound? In the olden days, Berzelius proposed a theory. That is Berzelius theory. So, what is the Berzelius idea means? You take any organic compound. All organic compounds could only be prepared under the influence of life. So, life force is required for the manufacture for the preparation of organic compounds. How means? Let us take an example. What is an organic compound? Means the compound which can catch fire is an organic compound. So around us you can see any compound. Most majority of the compounds are organic compounds that catches fire. Let us take paper. It is an organic compound. Let us take cloths. Organic compound. Let us take petrol. organic compound. Let us take diesel, organic compound. Whatever the food we are eating, that is also organic compound. Whatever the diet we are taking, that is also organic compound. So like that, organic compounds means the compounds which were prepared by life force. Example, let us take sugar. Sugar is an organic compound. How it is prepared? It is prepared from the plants. Cane. Cane is nothing but a plant. It is a living organism. It has a life. So for the manufacture of sugar, definitely we need cane. Cane. Cane is a living organism. So life force is required for the manufacture of organic compound. Not only one or not only two, all organic compounds. According to Berzelius theory, all organic compounds could only be prepared under the influence of life. Life force is nothing but vital force. We know that if there is a life, we have an activity. If there is no life, it is not no action, no nothing. So life force is said to be vital force. So vital force is required for the manufacture of organic compounds. That is the Berzelius theory. But the Berzelius theory was proved to be wrong by another man. Is that Wohler. Wohler proved that living organisms can prepare organic compounds. At the same time, without life also we can prepare. So Wohler proposed another theory. So what is the theory? Organic compounds can also be prepared without life. Life is not required for the manufacture of organic compounds. Before this, all organic compounds will be prepared only under the influence of life. But nowadays, Wohler prepared that organic compounds can also be prepared without life force, without vital force. Vital force is not required. He showed an experiment. What is that? He was taken a salt. Salt is a non-living thing. Normal salt. The name of the salt is ammonium cyanate. It was taken in the test tube. Wohler taken a salt in the test tube. The salt has no life, but prepared. On heating ammonium cyanate, we got an urea. According to Berzelius theory, urea is prepared under the influence of life only. But this man is saying that without life also we can prepare. How means he has taken a salt in the test tube and heated. He got an urea. According to Berzelius theory, urea means for the preparation of urea, we need mammals. Mammalian. The animals which gives the milk are said to be mammals. Their urine contains urea. So for the manufacture of urea, we need mammals, animals at that time. But now Wohler proved to be wrong, and this theory is wrong by Wohler. Wohler said that without life force also we can prepare organic compounds. What is that? He has taken an ammonium cyanate as non-living thing in the test tube and heated. He got it urea. This is the first organic compound prepared in the laboratory. After this, the next compound was prepared by the methane. The next compound prepared by acetic acid. So like that, many organic compounds are prepared in the laboratory without life force. So Berzelius theory is there in the field up to nearly 50 years. After that, the next theory was proposed by Wohler. There onwards, now we can prepare the organic compounds without life. This is the first organic compound prepared by Wohler. And second organic compound prepared in the laboratory without life is methane. The next organic compound prepared in the laboratory is acetic acid, and so on. Number of organic compounds are prepared in the laboratory. Like this, millions of organic compounds we cannot separate, we cannot study under one topic. We have to categorize. So that is said to be classification of organic compounds. So now let us discuss about the classification of organic compounds. Organic compounds mainly classified into two types. The first category, acyclic hydrocarbons. Organic compounds mainly contains carbon and hydrogen. So they are said to be hydrocarbons. Acyclic means which are not in the form of cycle, which are in the form of chain. They comes under the acyclic hydrocarbons. The next one, cyclic hydrocarbons. So which are in the form of rings, which are in the form of 3 rings and 4 rings, number of rings. All those cyclic compounds comes under the cyclic hydrocarbons. So organic compounds only classified into 2 types. First, what are they? Acyclic hydrocarbons and cyclic hydrocarbons. Only 2 types. Acyclic, cyclic. And acyclic hydrocarbons again classified into 2 types. Saturated hydrocarbons, unsaturated hydrocarbons. Saturated hydrocarbons, unsaturated hydrocarbons. So what are saturated hydrocarbons? What are unsaturated hydrocarbons? Saturated hydrocarbons, carbon compounds containing alkanes. All alkanes comes under the saturated hydrocarbons. All compounds which contain single bonds. All compounds, carbon compounds which contain only single bonds. Carbon compounds in which carbon valence is satisfied by 4 sigma bonds. They comes under the saturated hydrocarbons. So what are saturated hydrocarbons? Alkanes are said to be saturated hydrocarbons. So what is the first member of alkane? Methane. Methane is the first member. Ethane is the next member. Propane, butane, pentane, like that. All organic compounds, the carbon contains 4 sigma bonds. There are no pi bonds. There are no double bonds. So carbon compounds containing single bonds comes under the saturated hydrocarbons. What are the example? Alkanes. All alkanes contain single bonded carbon compounds. So they are said to be saturated hydrocarbons. Then what are unsaturated? Example, alkenes. Example for alkene is ethylene. Another example for unsaturated, alkynes. Example, acetylene. So these two comes under the unsaturated. Unsaturated hydrocarbon means carbon compounds containing double bonds and triple bonds. Carbon compounds containing double bonds and triple bonds comes under the unsaturated hydrocarbons. So saturated, unsaturated. Saturated and unsaturated both comes under the chain form only. That's why they are said to be acyclic hydrocarbons. Now come to the cyclic hydrocarbons. Now the cyclic hydrocarbons are classified into 2 types. Homocyclic hydrocarbons, heterocyclic hydrocarbons. Heterocyclic hydrocarbons. Homocyclic hydrocarbons. So they are ring form. Heterocyclic, homocyclic. Both contains cyclic form, cyclic molecules. So all cyclic molecules are classified into cyclic hydrocarbons. They are classified into heterocyclic hydrocarbons. Homocyclic hydrocarbons. What are heterocyclic hydrocarbons? Cyclic organic compounds containing 1 or more heteroatoms, like nitrogen, like oxygen, like sulfur. These are other than carbon, hydrogen. So they are said to be heteroatoms. So the cyclic compounds which contains other than carbon, hydrogen are said to be heterocyclic hydrocarbons. So what is an example? Let us take an example. It is in a pyridine. See that at each corner we have a carbon, 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 and also hydrogens. Along with the carbon hydrogen, we have a other atom. What is this? Nitrogen. Other than carbon hydrogen, hetero atom is there. That's why it comes under heterocyclic hydrocarbon. So cyclic hydrocarbons which contains carbon hydrogen along with one or more heteroatoms, maybe one or more than one, they are said to be heterocyclic hydrocarbons. So let us take one more example. Pyridine furan. See that here carbon, 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 hydrogen, hydrogen, hydrogen is there. Along with that we have an oxygen. It also comes under the heterocyclic hydrocarbon, heterocyclic hydrocarbon. Let us go to the homocyclic hydrocarbons. Homocyclic hydrocarbon means the cyclic form contains only carbon hydrogen, no other atoms. That's why they are said to be homocyclic. Example, homocyclic hydrocarbons. Again, they are classified into two types. They are said to be alicyclic hydrocarbons, aromatic hydrocarbons. Alicyclic hydrocarbons and aromatic hydrocarbons. Alicyclic means the cyclic hydrocarbons which contains only single bonds. They are said to be alicyclic hydrocarbons. Saturated cyclic hydrocarbons. Saturated cyclic hydrocarbons. How many? Let us take an example. See that the ring is made up of with only carbons, no other atom. It is cyclic, and at each carbon we see that 1, 2, 3, 4 sigma bonds. Cyclic and saturated. Saturated means carbon should form 4 sigma bonds. See that here 4 sigma, here 4, here 4. All carbons are made with the 4 sigma bonds. Cyclic saturated hydrocarbon. It is said to be cyclopropane. Cyclobutane, cyclopentane, cyclohexane. Like that, all alicyclic hydrocarbons comes under the homocyclic alicyclic hydrocarbons. Alicyclic hydrocarbon means saturated, cyclic saturated compounds are said to be alicyclic hydrocarbons. Come to the aromatic hydrocarbons. So what are aromatic compounds means? Organic compounds or cyclic hydrocarbons which contain minimum one benzene ring. Cyclic hydrocarbons which contain minimum one benzene ring are said to be aromatic compounds. Benzene ring, it is like this. Here double bond, double bond, double bond. It is said to be benzene. Minimum one benzene. This kind of benzene rings may be attached to two or more. So carbon compounds are cyclic hydrocarbons which contains minimum one benzene ring are said to be aromatic hydrocarbons. Aromatic hydrocarbons. Alicyclic. There are no pi bonds. Only cyclic saturated hydrocarbons. Alicyclic. Aromatic. Aromatic hydrocarbons. The best example is benzene and its derivatives. Carbon compounds, cyclic hydrocarbons which contain minimum one benzene ring are said to be aromatic hydrocarbons. So this is the classification. Organic compounds are only classified into two types. What are they? Acyclic hydrocarbon, cyclic hydrocarbons. Next, acyclic hydrocarbons are classified to saturated hydrocarbons, and saturated hydrocarbons examples are alkanes. Unsaturated, alkenes and alkynes. Saturated means there are no pi bonds, only sigma bonds. The carbon valence is satisfied by 4 sigma bonds. So they are said to be saturated hydrocarbons. What are unsaturated means? carbon compounds containing minimum one or more pi bonds. Double bonded compounds and triple bonded compounds comes under the unsaturated. And next, cyclic hydrocarbons are classified into heterocyclic hydrocarbons and homocyclic hydrocarbons. Heterocyclic hydrocarbons are nothing but cyclic organic compounds containing one or more heteroatoms, like nitrogen, sulfur, oxygen, any other atoms. Homocyclic hydrocarbon means the cyclic compounds containing only carbons. See that here also. All are the rings made up of with carbons. Here also, the ring is made up of with only carbon, hydrogen, no other atom. That's why these two comes under the homocyclic hydrocarbons. In our syllabus, we have alkanes is the first topic, and alkenes the second topic, and alkynes is the third topic, and benzene. Benzene is the last topic. So we have alkanes, alkenes, alkynes, benzene. Apart from that, we have a little fundamentals and naming. Because day by day, the number of organic compounds are increasing. For each and every organic compound, we have to give the name. Name is required for recognition of a carbon compound. So, how to give the name is a very difficulty without any rules. So, that's why the naming of organic compounds is the other utmost important in the organic chemistry. So, naming of organic compounds, isomerism, and then we have an alkanes, alkenes, alkynes, and benzene. So total we have naming of organic compounds, alkanes, alkenes, alkynes, and benzene. Now we'll discuss about the naming and bonding of organic compounds in detail. Bonding in hydrocarbons or carbon compounds. Now, the main important one is carbon. Its atomic number is 6. How it forms the bonds in the carbon compounds. So, the bonding is also very important. Now, carbon atomic number 6. Its electronic configuration 1s2, 2s2, 2px1, 2py1, 2pz0. And this is said to be ground state electronic configuration. Ground state electronic configuration. At the lowest temperature, the carbon exists this kind of electronic configuration. So, the atomic number of carbon is 6, 1s2, 2s2, 2px1, 2py1, 2pz0. Now, how many unpaired electrons? The number of unpaired electrons are, see that. Here 1, here 1, here no. Here we have 2 electrons. Now, the valency of carbon. Valency of carbon means number of unpaired electrons. How many are there? 1, 2. So, the valency is 2. It is also to be divalent. So, divalent means it has to form only 2 bonds. If any atom contains 1 unpaired electron, it forms 1 bond. If there are 2 unpaired electrons, it will form 2 bonds. If there are 3 unpaired electrons, 3 bonds. 4 unpaired electrons, 4 bonds. Now, number of unpaired electrons, how many are there? 2. So, the valency is equal to 2. The carbon valency is 2. But carbon is forming 4 bonds. That means, at the lowest temperature, we have carbon valency is 2, divalent. But at room temperature, always carbon can form 4 bonds. At room temperature, what happens? It absorbs energy, excitation energy, and it forms 1s2, 2s1, 2px1, 2py1, 2pz1. Now see that it is said to be excited state electronic configuration. Excited state electronic configuration means after absorbing some of the energy, one of the electron is promoted from s orbital to pz orbital. Now what is happening? One of the electron is transferred to pz. Now single electrons, how many are there? In the last orbit, it is said to be tetravalency. So this is a tetravalence. That means always at room temperature it will be like this. That's why carbon forms 4 bonds. And it has highest catenation property. These two are responsible for the formation of large number of organic compounds. So in this state, carbon participates in hybridation. 4 types of hybridation, 3 types of hybridation. So what are they? sp3 hybridation, sp2 hybridation, sp hybridation. So we'll discuss in detail about the shapes of molecules, and up to that we have to know atomic number of carbon and valency. Valency is 2, divalent in the ground state, tetravalent in the excited state. So what is the valence of carbon is? You have to ask a question. Either ground state or excited state. Excited state, no need to ask because at room temperature. Valency is to be explained always at room temperature. At room temperature, carbon exists in the tetravalency. So carbon tetravalency and catenation, both are responsible for the formation of large number of organic compounds. So this is about the carbon atomic number, electronic configuration in the ground state, electronic configuration in the excited state. So in this state, carbon forms participate in 3 types of hybridations. sp3 hybridation, sp2 hybridation, sp hybridation. Carbon participate in 3 types of hybridations. sp3 hybridation, sp2 hybridation, sp hybridation. So the details we'll discuss in detail after the knowing of these 2. So this is about the valency of carbon and bonding. We are going to start the bonding after the next class.